This gonna move me forward?
Yeah,
Maybe not.
it should.
Well, it's a PDF, so I may have to come back.
Okay.
Okay. Well, thank you, and I do appreciate having the opportunity to thank the HTCondor community for everything it's taught me over the years. I came into the LIGO collaboration about 10 years ago. I did have a computer science background, but I had no background in distributed computing. And honestly, forums like Condor Week have, given me so much over the time that I'm glad we had the opportunity to give a little back last night. You guys are actually literally the first to know about this in the general public, but Google Cloud has a new product coming out literally today. Some of the links in the PDF aren't going to work if you're at home, so forgive me. It's still 8 a.m. on the West Coast, so we haven't actually clicked all the buttons yet. But it's called the Cloud HPC Toolkit, and our goal is to make it easy for customers to and partners to deploy repeatable turnkey environments that follow Google Cloud's HPC best practices. I'm fully aware HPC is a little bit of a dirty word here. In our categorization of things, high throughput computing, batch computing, and HPC all kind of fall under the same group of people. But what I think about when I see this slide is the out-of-the-box experience of using Google Cloud for large-scale computing ought to be easy. You ought to not have to think about some of the things that when you go to our documentation, you're forced to start thinking about and learning new concepts. So, the out-of-the-box experience ought to be easy, but at the same time, it ought to be flexible enough that you can actually do more complex configurations. Condor on Google Cloud, historically we've supported it using a solution called Deployment Manager. That's a Google Cloud specific technology, which is great because it works on Google Cloud. It's less great because people like you want to learn more generic tools that work across cloud providers or work in your on-premises cluster environments. So it's something we're moving away from in our support for the research community. And so we're starting to move towards more open source tools. The toolkit is built out of, or has direct support for tools called Terraform, Packer, and Ansible. I'm sure most of you are familiar at least with Ansible. I'll talk a little bit about Terraform later. And our goal here with respect to Condor is to be able to support dedicated pools. What that means to us is the pool is entirely in the cloud, or hybrid pools where you have some on-premises component that may burst temporarily into the cloud to serve a job. Taking a step back from the toolkit, thinking about what we've added support for in Condor in the cloud. Right now, we have solutions that will scale a homogeneous pool based on the length of the queue, entirely in the cloud. About as simple as you can get. Count the number of jobs, count the number of cores, maybe count the number of GPUs even, and provision the number of machines necessary to meet the demand of that job. Limited, of course, in the fact that it's a homogeneous pool. So one type of machine can go up and down. Todd Miller, in particular, has been helpful the last year or so in adding new features to to Condor to help support cloud. So now in 9.2 and above, we support cloud storage. Cloud storage I'll get into in a moment, but it's a object store file system, which scales very well for a large number of jobs. In 9.4, we added cloud native machine class ads. So a Condor machine now advertises properties that are useful for matchmaking in the cloud. Coming soon, there will be a opportunity to add cloud native class ad attributes to your jobs. And then on the roadmap, where and the main topic of this talk is going to be improved auto scaling in the cloud. So I showed these slides at a recent Condor week, so I won't spend too much time on them, but cloud storage is not a shared POSIX file system. It's actually HTTPS accessible objects. It's when you actually access cloud storage, we, on the back end, we monitor how heavily you're using it, and we can actually react and start duplicating the data in order to facilitate really high transfer rates. There's also, comes high performance out of the box, so you can get, extremely high bandwidth without a whole lot of effort in writing a client. And on top of that, of course, it comes with, real professional resilience guarantees. So it's duplicated throughout a region in multiple locations, so that even if one server goes down, you're not going to lose your data. This is directly supported in 9.2, and you can kind of hack your way into it in 9.0 if you're using the LTS release. One of the most important properties of cloud storage is its location. Typically, we recommend customers go with regional buckets. A region is, you can think of it as several data centers that have independent availability failure domains. So, one data center within a region can, lose its power, and the rest of the region will stay up. But I think one of the neat things that has come out in the past year is support for dual region buckets. So you can actually specify from a set of regions and say, I want my data to be stored in US East 1 and US West 1, and Google will take care of duplicating the data when you write it to the two disparate data centers or regions, excuse me, and you can access the data. You can provision compute in either of the regions and get both the cost and performance benefits of being close to the data. 9.4, we added a single meta knob that adds cloud attributes to your machine class ad. Most of these hopefully make sense to you. So, but one point I'd like to emphasize is, even though I work here for Google Cloud, I know that one of the things that is important to the research community is openness. So we have not actually written this in any kind of Google Cloud specific way. These are just attributes, and I believe Todd has even implemented this exact functionality for AWS and EC2 attributes. So these attributes are important for the actual cost and performance of your workflow when it's running in the cloud, because you want to know where your data is relative to your machine. The instance ID is actually my favorite attribute here, because that's a unique identifier for a machine. So if this instance ID can be added to your job history and you see some kind of problem with your job, you can actually work with the cloud support team, and we can actually say that was this machine in this rack at this moment in time. I've actually had this code ready to go for a while, but I've been waiting for the dual region support to come out and have a clear API in it. So this is a one-liner for adding job cloud class ad attributes to, cloud class ad attributes to your job class ad. That didn't come out well, but I think you got it. And so, very similar to the machine attributes, it's going to tell you where your data resides. That's GCS is short for Google Cloud Storage. And the location, in this case, I'm given a demonstration of a dual region bucket.
Yeah, it's related to the bring your own capacity of the previous talk, and going more into the access point, the smartness. But these attributes can help the access point to launch the environment in the cloud
Yes.
in order to support the job. Because by looking at the job, it can say, hey, given where the data is,
Yeah.
and all this information, I can treat it differently than other jobs. So all this is really moving in let's call it the right direction.
Yeah.
And we really appreciate your feedback on that, because you obviously are looking at it from the cloud provider perspective. But for us, it is how do we best present it to the researcher?
Yeah.
So we can do behind the scene using what you offer.
Yeah.
So because there's more and more data that is being stored.
Yeah.
In your under this system.
Yeah.
And we have more and more researchers that would like to compute on it. And the question, how do we make it end to end? So this is wonderful.
Yeah, yeah. One of the things I'm trying to think about here as we do this is, how does Condor actually work, right? And it's class ads. And nothing about this is saying, well, you have to give me a machine in Google Cloud. It's just saying, here's some information that would allow you to give me a better machine in Google Cloud, right? One thing I want to point out here is I'm not exactly fond of the syntax in blue. It's a little bit kind of, I don't know, clunky, because it's mixing command, submit syntax with $signs and stuff like that. It is repeatable. But one thing that's kind of became clear is that job transforms that run in the SCED, the reason you can't use that feature here is because the access key ID and the secret key for talking to our cloud storage API, they're going to be in the file system of the user at the time of submit. So having some kind of way of maybe a prettier way of doing like job transforms with the credentials of the user without blocking the scheduler, that might be useful. So to Marone's point here, the story I'm trying to tell here is the possibility for a pool that auto scales globally in the direction of the data as the job kind of advertises itself. And so when I say global, I actually mean global. Google Cloud has 33 regions with, I think, 100 zones within the regions. Every blue dot there is a region, and the number is the number of zones within that region. And then the white dots are places we plan on building regions. All the little gray dots are hop-on points from the regular internet into our Google specific network. The darkest dots are places that a institution like University of Wisconsin would have a direct connection through internet into Google Cloud. So it's a it is one of the largest networks on Earth, if not the largest. So this is where I'm hoping to get. So the idea that Todd Tannenbaum mentioned in a meeting and then came up at the last European workshop was the possibility of using offline machine class ads as a way of driving auto scaling. And it actually kind of worked its way into my brain and made it, I didn't initially think it was the right idea, but then I compared it to a solution we have with Google Cloud has with SCED-MD and Slurm, and they're using essentially the same feature. So offline machine in Condor is a class add that represents a machine that hasn't been powered down. This dates back to the early 2000s when you would want to save a few bucks on electricity. So you would power down an idle machine, and then you would wake it on its LAN port. And we're using the same feature in Slurm to drive auto scaling of Slurm in Google Cloud. And it's really the right answer in part because it's using the scheduler both in Slurm and in Condor to perform matchmaking. So when we do this with Slurm, a job actually matches to the offline equivalent of the machine. A script runs to power it on, but in Google Cloud is actually turning the machine on in order to serve that job. And you know that that action is going to be worth the money that it costs because Slurm said, I'm going to match to this job. I'm certain that this machine will be useful if you turn it on. And so the same idea applies to Condor, except that Condor has a less rigid notion of partitions and whatever. It's every member of every execute point within a Condor pool is kind of a free agent. So instead of having a set of offline machines, each representing a single machine, what I'm trying to work on with Todd is a single class add that actually represents a scalable resource of machines. I think this is a good sustainable way for doing things because it doesn't tie our customers to any particular backend implementation. So kind of the default answer here would be to use a managed instance group, which is a resource where you say, I want 100 machines, do your best to give me 100 machines. But maybe in 2 years, we have some other alternative solution that Google Cloud would prefer our customers use, or a customer has some specific reason not to use instance groups. And this allows us to kind of use Condor for what it's good at and then implement the backend in our own preferred way.
Did you consider to have some kind of feeder of these empty slots? Because that can also be used to limit you from a runaway. So you have somebody that says, okay, let me put another 5 empty slots.
Yeah.
And if they are being used, I may give you another 5.
Yeah.
But I will stop. I'm not going to go beyond 20.
Mm-hmm.
But I control it through these slots, and you don't bury these decisions of the watermarks.
Yeah.
Into the lower level, but you put in some kind of an agent that says, let me give you a few empty slots. Let's see if you can use them.
Yeah.
So that's a possible way to address it. So you don't have a single slot that represents 100 machines,
mm-hmm.
but you keep the number of slots, because typically you don't grow from 1 to 1,000 in one step.
Yeah. I mean, initially you might, but after that point.
But then you should use something different.
Yeah. Well, I mean, frankly, this doesn't exist yet. So this is something that we can. Yeah. Well, no, what I mean is this doesn't. I mean, this is an idea Todd and I have.
But I want to feed.
Yeah.
to
feed
your discussion.
Okay. So coming back to the toolkit. So the principles of the toolkit are openness. So it's on GitHub. I checked right before the meeting. It was still private, but the link on one of the next slides should come up later today. Subject to review, open to pull requests. We have a method for community contributions. Configurable. So one of the things that people tend to have difficulty with in the cloud is customizing machines. So, in your on-prem environment, you probably have Puppet, Ansible, Chef, something like that, configuring the machines. And in the cloud, we basically give you a vector of a startup script that runs at boot. And that startup script might be kind of hacky, run set, grep, all that kind of stuff, or it might call back to something like the Puppet server, or something a little more professional. And with the toolkit, we're actually making it a little easier to do the kind of customization that we need for HPC applications. I think the big challenge in supporting HPC in the cloud is that you not only have the application of Condor, or other schedulers, but you have the actual application people care about. And that kind of dual layer of things is actually tougher than you might think to support. So the toolkit starts with blueprints. These are a YAML file that specifies essentially Terraform modules and Packer modules and Ansible scripts that are then combined by a command line tool called GHPC into a deployment folder. That deployment folder is likely to be mostly Terraform modules. And then you run Terraform to actually provision your environment on Google Cloud. I'm wagering that most of you haven't used Terraform or maybe even heard of Terraform. The good news is that Terraform represents hardware in the cloud as a DAG. So most of you probably have experience with DAGman. And it will provision infrastructure according to the implicit dependencies that you specify in a module, as well as any explicit dependencies. So in this simple model here, I've created a global network. I've created a subnetwork in a region, and then an IP address within that subnetwork. And then the IP and address and disk are prerequisites for the machine to do something, right? You can't actually have a machine turn on without a disk or an IP address. So all those dependencies are implicit. Meanwhile, with firewall rules, you can have a VM come up without firewall rules, but it won't function. So you actually have to declare that dependency explicitly. Here's an example blueprint. This, maybe 50 or so lines of YAML turns into an actual auto-scaling Slurm cluster because it's making use of several modules under the hood that all have kind of best practices and good defaults in them. So the Cloud HPC Toolkit, the formal announcement is coming on Monday. My boss has called today the soft launch. So that repo on the second bullet there is hopefully going to be available later this afternoon. There's a Condor branch that I'm working on right now, and we're planning on merging it shortly after release. It supports ID tokens out of the box, and it's installing the latest 9.x series rather than the LTS because Todd and I are actively adding features. One thing I wanted to mention was going back to my old job working for LIGO, I'm very aware that one of the biggest challenges is actually just literally figuring out how to pay the cloud. And the NSF and Google are trying to make that easier every day. There's a number of awards that are all tied into a project called Cloud Bank, which allows the NSF to award you money, and then you can directly use that money on a cloud provider of your choice. And then we have a number of discounts available to primarily research institutions. Right now, that takes the form of a data egress waiver up to some percentage of your bill. So thank you. I appreciate it.